Hello students, welcome back to science class with Miss Elisa. So today we are going to learn about an instrument that can be used to measure the length of an object very accurately. Alright, now can you guess what kind of instrument is that? Alright, good, it is Vernier Caliper. Okay, so actually in the previous lesson we have learned about Vernier Caliper briefly. So today we are going to learn about it more specifically. So what points that we are going to discuss? Let's check it out together. Alright, first, what is Vernier Caliper and what is the function of this instrument? And then the second, what are the parts of Vernier Caliper? And then the third, how to read the measurement of Vernier Caliper. And the last, we are going to learn about the zero error. Okay? So, let's check it out one by one. What is Vernier Caliper? Vernier Caliper is one measuring instrument that we use to measure the length of an object very accurately. So, what kinds of length that can be measured by this instrument? The first, internal length. The second, external length. And the last, it is the depth of the object. Okay? Next. Let's check the parts of Vernier Caliper. So actually, I bring one here. So I'm going to show you directly. Okay, so here I bring you the Vernier Caliper. Let's see. Vernier Caliper consists of two scales. So the first scale is the main scale, and the location of the main scale is here, while the second one is Vernier scale, and the location of the Vernier scale is here in this part. Okay? So at the upper part is the main scale and the lower part is Vernier scale. Okay, so another parts are the lower jaws. I think this is the most prominent part of the Vernier Caliper, yeah. So this is called as lower jaws. And at the opposite, at the upper part here, this is the upper jaws. Okay, one of the jaws here is attached and fixed in the main scale. Just the same with the lower jaws here, one of the jaw is attached and fixed in the main scale, while another jaws, like this one and this one, the location is different. The location is in Vernier scale, like here and here. And guys, for these jaws, they are movable. Look, I can move them. So when we do the measurement, this is what we do. We move the jaws until we get the fixed measurement. Okay, what about another part? Look here. So, this is lock screw. As its name, the function of lock screw is to lock the jaws whenever we do the measurement. So, for example, we got the measurement like this. So, to make this fix, we just locked it. So, when we locked, there is no movement anymore. When we lock, there is no movement anymore. Okay? Alright, what about another parts? Here we can see this one is thumb screw. What is the function of thumb screw? Okay, so actually when we are going to move the jaw, this thumb screw will help us to adjust the movement. So like this, we can just put our hand here and then we move it. So the last one, it is the depth rod. So as its name, the function of the depth rod is to measure the depth of an object very accurately. So like the depth of the tube, the depth of cylinder, or something like that. Okay? Okay, the next, how to read the measurement of Vernier Caliper. Let's check it out.
Everyone, this is Vernier Caliper. Look, so this is the zero line in the Vernier scale, and this is the zero line in the main scale. Are in the straight line or in the same line, right? So here, the measurement that we got is 0 millimeter. And then, if we try to open the Vernier Caliper like this, okay, so here we have 1 millimeter, and then here 2 millimeters, here 3 millimeters, then 4 millimeters, and then 5 millimeters, and then here must be 10 millimeters. And then here 15 millimeters, and here 20 millimeters absolutely. But what if the zero line is between 21 and 22 here? Well guys, we must use the vernier scale. This is the vernier scale from here to here, and the main scale is this part, yeah. So guys, from here to here, the vernier scale represents 1 millimeter, and each line here represents 0.02 millimeters, 0.02, and then 0.04, 0.06, 0.08, and 0.1. So now back to the question. What if the zero line of the vernier scale here is between 21 and 22 of the main scale? So what we have to do? Alright, we have to use the vernier scale. But first, we have to notice the measurement in the main scale. So here we got 21 plus something more, right? So we have to write 21 plus something more. So we are going to find another number by using the vernier scale. Alright, what should we do then? So now we have to find 3 lengths of the vernier scale which have the straight lines to the main scale. Alright, let's find it together. This one. 1, 2, and 3. But we have to choose the center. So this one. We have to make the mark. So here is 50, 52, and then 54, right? So we have to write 21.54 millimeters. So this is the measurement that we got.
Now let's try to measure by using objects. I bring test tube. Alright, let's check it out again.
So here I'm gonna show you about how to use the Vernier caliper and how to read the measurement by using some objects. So the object that I bring here is test tube, and we're going to measure the length of the test tube, like internal length, external length, and the depth of the test tube. So first I'm gonna show you how to measure the external length of the test tube. So we have to put the position like this by the help of the thumb screw like this to make it a fixed position. Okay, after we got the fixed position, we have to lock it by using the lock screw here so that the jaws can't move anywhere. So we got the fixed measurement. After that, we have to see the main scale and the vernier scale to read the measurement like the previous way. Okay, so after we got this, we have to unlock it again so we can open the jaw. Now I'm gonna show you about how to measure the internal length. So by using this one. Okay, we can adjust it by the thumb screw here. Alright, and then we lock it again to get the fixed position. So we lock it again to get the fixed position. So after we make a locking like this, we cannot move. Look, we cannot move the position of the jaws anymore. So we can get the fixed measurement. Alright, so this is the way how we measure the internal length. Now we have to unlock it again. Now how to measure the depth? We put the position of the object like this. So okay, like this until we get the fixed position. So like this. Alright, and then after we get the fixed position, as usually we have to lock it first, and then we read the measurement from the main scale and the vernier scale. Okay?
So for the first measurement, namely by using the test tube as the object, right? So we got the external length is 16.10 millimeters, while the internal length 13.50 millimeters, and for the depth or the height we got 148.70 millimeters. Okay, so now we come to the zero error. So sometimes in one condition we find something called as zero error. What is zero error? Okay, so if the jaws are closed but the zero marks on the main scale and the vernier scale are not in line, there is an error called as zero error. So let's see the picture. Okay, from picture A, we can see the zero mark at the Vernier scale and the zero mark at the main scale are in the same line, right? So it is not the zero error. Picture B. You can see the zero line of Vernier scale is not in the same line or is not in the straight line of the main scale. So in this case, there is an error occur. It is called as zero error. So when the position of the zero line of Vernier caliper is on the right, it means the zero error is positive zero error. While, look at picture C. When the position of zero line of the Vernier scale is on the left, it means the zero error is include to negative zero error. So now, can you differentiate between positive zero error and negative zero error? Okay. So I think that's all for today. I hope you enjoyed the lesson, you enjoyed the learning process. See you guys in the next science class. Bye-bye.